Okay, let's do question number 6. The final question, the final SB question in chapter 6. Question 6 is the final question in chapter 6. And what we have here is a ramp. And we're moving a box, a crate, up the ramp. This distance here is 2 meters. Let's see what we got. Suppose you wish to compare the work done by pushing a box up on rollers. So there's rollers. The idea of the rollers is you minimize friction, so we're not going to worry about friction. How much work is it to roll the box up the hill compared to how much work is it to lift it straight up? What do you think? How do those two works compare? So, question A. What is the work required to lift a 100 Newton box, about 22 pounds, up to a table which is 1 meter off the floor? So this height is 1 meter. 1 meter. Okay, so that means you're pushing straight up. You're pushing straight up, so your force is in the direction of motion. It's directly parallel. So we can use work is equal to force parallel distance. I need some work on my arrows. So work is equal to the force. Well, this is a 100 Newton box. So the minimum amount of force you need to lift up that box is 100 newtons. The box weighs 100 newtons. That's the force down, 100. That's due to its weight. So how much force do you need to push it up? Well, you need a minimum of 100 newtons force up to push it up. If you do that, then it's not accelerating. So that's the force that we want, 100 times the distance. Well, you're moving it up 1 meter. So the work done and pushing it straight up is equal to 100 joules. B. Let's assume you also have a ramp available that makes an angle of 30 degrees with the horizontal as shown. The ramp is 2 meters long, we know that. The weight of the box is 100 newtons, we know that. So this 100 Newton force is directed straight down. So we got 100 newtons directed straight down. So some of that 100 newtons is being supported by the ramp. However, we know if there's no friction, it's also going to slide down this way. If you push the box up the ramp, you are doing work against only the component of the weight of the ramp, which is 50 newtons down the incline. So this ramp, in this particular case, is supporting half the weight. So that means there's a 50 Newton force due to gravity pulling it down. Gravity is really pulling it down 100 newtons this way, but this component of this force at an angle of 30 degrees is 50 newtons this way. And we want to know how much work does it require to push the box up the ramp. So we have work is equal to force parallel distance. So we get the work to push it up the incline. You have to overcome this force. The minimum amount you use is equal to that force 50. Otherwise, you're accelerating it if you use more than 50. You can use more than 50, but then you're accelerating it. The minimum amount that you need to push this box up the hill would be 50. The distance it has to travel to move it up the incline is not 1 meter, it's 2 meters. You're using 50 Newton force to push it up the incline, and the distance here is 2 meters, so it's 50 times 2. So the work done is equal to 100 joules. Notice it's the same amount of work, whether you slide it up the incline or you lift it straight up. It's the same amount of work if and only if there's no friction. Remember, there was no friction here. You're using a lot less force, 50 as compared to 100, but you have to push it 2 meters instead of 1 meter. Right? Lifting it up, you just lift up 1 meter. If you're going to push it up the incline, you have to push it 2 meters. So in the result, you're using half the force, but over twice the distance. So the work done either way is the same. Part C says, which situation, pushing up the ramp or lifting straight up, requires more work? Requires more work. Well, it's the same. We just calculated it's the same. So it's the same. Again, assuming no friction. Part D. Which situation requires more force? Well, we answered that too. Lifting straight up requires 100 newtons of force. Pushing it up the incline only requires 50. So which situation would be pushing straight up? Pushing straight up requires more work. Well, it requires more force. Requires more force. It's the same amount of work. Part E. For which situation is the distance moved greater? Well, again, pushing it up the incline is 2 meters as opposed to 1 meter pushing it straight up. So pushing the mass up the incline requires a bigger distance. A, B, C, D, E, F. What is the change in gravitational potential energy of the box for each situation? Well, the final height's the same. It's 1 meter high. Right? Height is straight up. So they're the same. So potential energy is going to be the same in both cases. It's just mgh. This is not height. This is height. So the height's the same. The mass was given to be, well, we don't know what the mass is. We have to calculate what the mass is, but we know what the weight of the box is. The weight of the box is equal to 100 newtons, but weight is also equal to mg. Our g is equal to 10, so what times 10 is equal to 100? The mass must be equal to 10 kilograms. So plug in 10 kilograms, plug in 10 kilograms for m, we get 10. G is also 10, and the height is 1. Whether you roll it up the incline or push straight up, the final height is 1 meter. So the potential energy then is equal to 100 joules. Notice that, once again, it's the same as the work done. Same as the work done. Part G. Oh, a lot of parts to this problem. What advantage, if any, is there to using the ramp? Well, the advantage is you require less strength. To push the box up the incline. You only need 50 newtons of force, whereas to push the box straight up, you need 100 newtons of force. And that is the answer to number 6. Good.